So go to page 8. I'm just gonna jump back and forth. Page 8. So I need you to be comfortable going from probability to odds and going from odds to probability, right? Going back and forth. That's like the first skill that I need you to be really good at. So whenever, I can tell you something here that might help you. Whenever you see odds like this, you can immediately think of two probabilities coming out of that one. It could either be 1 over 1 plus 11999, which is 1 over 12,000. Can you see that? Yeah. Or it could be 11,999, like if you're referring to this number. We'll find out in a bit what that number represents. Also over 1 plus 11,999, which is just this. Okay, so from odds, you can actually get two probabilities out of that one. One is probably of that thing happening, probably against something happening. But what do you see? What would they add up to? Can you tell that these would really just be 100% or 1? Can you see that? If you add these fractions, you get 1, right? So there's ways to kind of think of it this way. So I will say this is probability, right? These are your odds. So don't mix them up. Sometimes I've seen exams where it's like, state the probability of this happening, state the odds of this happening. And students stick to probability mode, they answer it wrong, okay? Odds, you want to answer it like this. I know some of you learned odds, stating odds as fractions in younger years. Anybody have that? Like some teachers may have told you, hey, you can state odds as fractions. I will not do that because that's a train wreck waiting to happen. I stick with this notation when it comes to odds, okay? All right. Let's read again. The odds of, okay, that's important. It's not odds against, it's the odds of. What is it? What are we talking about? Of lightning. Right? So there's odds of or odds against, and then there's that certain event that it's referring to. When it's odds of, then I know that this is lightning, and it compares it to the instances where it's not. It's just not going to happen. Okay. So based on the way it's worded, I know what the numbers represent. Okay. So now I can move forward. So technically, if you think of the probabilities that I came up with, this would be the probability of lightning, this one, and this is the probability of it not being struck by lightning, right? So that's what I've come out of the odds. I was able to come up with both of the probabilities, so they go hand in hand. Okay. Common mistake is students just slap the 11,999 in the denominators. That's wrong. Okay, so you might think, well, it's close. You're off by 1, but it's the concept. You're off with the concept. So state the probability against being struck by lightning. So you're going to go probability of, right, this not happening. Which one am I going to grab? I'm going to grab this one here. Okay, where I picked that, the not happening, I put that on top. And the denominator, I'll just add. I show that I'm adding because it's a good reminder. I usually actually recommend you do the adding first. Okay, this is your total. So there we go. Very small number as a decimal, so I'm not even going to bother writing it as a decimal. When that happens, just state it as a fraction and you're good to go. State the odds against being struck by lightning. If it says odds against the event, guys, it's asking for this. Lightning will be here and not lightning will be up first. Like it basically wants the not happening first. That's what it's asking you for when it's against. Against. Okay. Here, I'll do it one more time. Odds of would be 1, 2, 11, 999, right? 11,999. Odds against, it's the exact opposite. All you do is flip the original. So if you have odds, just flip the original. Next, out of 850,000 people, how many are likely to be struck by lightning? This is what I would suggest here, okay? I'm going to give you like a mini, I know my key did it a different way. Maybe I'll just stick with the key because I showed you, I did the OR, okay? I did OR on my key. So I'm going to say prediction. You just go probability of that happening times the sample that you're considering. So what's the probability of being struck by lightning? I already did the work for us earlier. Watch here. It is actually, that is the probability of being struck by lightning. 1 over 12,000. So I write down 1 over 12,000 and multiply it by the sample. That's, to me, the fastest way of getting your answer. And remember, we're talking people, so you got to round to a whole number here. So see how small that is when I divide? It's to the -5, right? Times 10 to the -5. When I multiply it by 850,000, it's 70.83, and that keeps going. So we would say approximately, it doesn't matter if you go 70 or 71, but the province doesn't want decimals there. People. Okay, there we go. Probability in A, is that theoretical or experimental? It is actually experimental, right? Based on previous, right? On actual occurrences. I mean, I hope they didn't perform trials, right? Go stand out there in the field. And if you start getting goosebumps, right? Just don't move. I hope they didn't do that. But anyways, yeah, it's based on actual occurrences. So in this case, we would consider this an experimental probability. Okay. All right. Let's go to page 9. I'll give you so I'm going to mix it up. Odds, probability, odds, probability. So we're not going to do the whole thing, but I will ask you to try question 1. So you do 1A, B, C, D. And you knew this is, there's A, so the deck of cards. You need your deck of cards for the first 2. The next one, you don't need deck of cards. Everything is given. And then another odds, and I asked you to find the probability based on that. So try A, B, C, D, maybe split it into 4 and try to answer. I didn't assign that, did I? I don't think so. Yeah, so let's try that. See if you're able to answer. And I'm thinking question 3 as well. So 1 and 3. We'll It'll take some time. Instead of an AC, we'll just do that right now. I'll post the key to this entire thing if you want to give it a try. But I think the next section is deserves more attention. So I'll just answer the following. Determine the odds. So make sure you don't miss that. Probability versus odds. Okay, the odds in favor of choosing a face card from a deck of cards. So when it comes to A, because it's worded that way, you want face compared to cards that are just not face cards. That's always what odds do, right? So there are 12 face cards, and we know that there are 40 that aren't. I like to think of total minus face cards, so it's 12 to 40. It didn't show you how to reduce odds. This is pretty easy to just do probably by hand, but treat it like a fraction, guys. Watch, you go 12 divided by 40, right? And then you go math, fraction, and so you know it's 3 to 10, okay? But 12 to 40 would have been okay with me, okay? B, determine the odds against choosing an ace. So because it's worded that way, you want cards that are not ace cards first and then ace second, okay? If you figure that out, the rest is really just plug in and go. Which one do you think I'll plug in first? I always choose to focus on ace cards, right? So 4 ace cards, and then this will be 52 minus 4. So it's 48 to 4. 4 goes into both of them, so it's 12 to 1. On a test, maybe don't simplify, because if you simplify and it's wrong, then I have to take marks off. So C, the probability, oh, different color, right? Now we're in the probability territory of an event happening is 2 to 5. I state the odds against, so I have to switch again. Okay. We want to state odds against that event, whatever it is happening. So we're having probability of event is 2 over 5. We know this is the total, right? Like that's how probability is different than odds. And so for odds against, that means that we want the instances where the event is not happening first, followed by them happening, because it's worded like this. So which number do you pick? You pick the 2, you put that here. Okay. And over on this side, you're going to go 5 minus 2. So it's 3 to 2. That's how you do it there. D, the odds in favor of choosing a female is 35 to 55. So 35, 55, odds in favor, that means this is female, not female. That's what we know. So probability of choosing female would be 35 over, you add them up, 35 plus 55. So it's 35 over 90. Okay, and yes, you can reduce that. That's 7 over 18. Yeah. Didn't ask decimal. If it doesn't ask, just leave it as a fraction, okay, guys? Don't turn it into a decimal. Don't turn it into a percentage. Just leave it as a fraction, and you're good to go. I would say don't even reduce it. On the exam, for sure, just leave it. Because then you get full marks if you have done that right. Okay, so moving down to question 3 here real quick. You've got 2 games, and both of them mention odds against. I should have probably gone odds against and then odds in favor just to really mix you up there. But hey, it's all right. So that means that for Zim, we have 5 to 2, right? And we know that against winning. So that means that winning is here and not winning is the first number. And for Zap, it's the same thing. If you have 7 to 3, then this is not winning and this is winning. So I should probably highlight the winning part, right? That's the event we're after. That's the event we're after. So probability of winning for this game would be 2 over 5 plus 2. So it's 2 over 7. Whereas Zap would be the probability of winning would be 3 over 7 plus 3, which is 3 over 10. Some of you can tell there already, but the best is to turn them both into a decimal. What do I have here? This gives me 0.2857, and this gives me 0.3, right? And so this one has a higher chance. Higher chance. Not by much, but it is bigger than 0.2857. Okay, so this is like going between them all the time and making sure when it's odds against that you know what do the numbers represent. Okay, that's very important for odds to know which number is what. Okay, I know it's so question 5. I'll leave that when I post the key so you can check there if you want to check, right? It's similar lines as to what we've done. Or do you want me to do it? I'll leave it for now. If I have time, I'll do it later. So I'll stop this here and we'll go to our next